In this section, we will learn about secure remote access. We will begin with a discussion on remote access goals and methods, and then we will look at three particular ways to access our pfSense installation or network. We'll begin with a look at OpenVPN, followed by using IPsec and Level 2 tunneling protocol, and we'll conclude the section with a look at two different ways to use SSH to access your pfSense. So let us begin our discussion on remote access goals and methods. If you are interested in remotely administering your pfSense installations, there are two primary methods for doing so. The first would be to enable secure access to the pfSense web configurator by allowing traffic on port 443 from the wide area network. The other option would be to allow traffic from the wide area network to access port 22 for secure shell access. It is important to note that if you do this on a machine which is reachable by the public internet, that you would most definitely want to use a whitelist of IPs approved for access to those ports and deny all other traffic. It would also be wise to run those services on non-standard ports so that you will not be susceptible to traffic scanning robots. Let me be very clear about this point. You must only allow trusted IPs to access pfSense remotely. There are many robots running rampant on the internet, and they will use all sorts of brute force methods to try to access your firewall machines, which would allow them access to all of your internal resources. We will also be interested in securing remote access to and from other networks going across the internet. And to do so, we will use virtual private networks. pfSense comes with three types of virtual private networking software installed. One of those is IPsec, which is a modern and robust protocol well suited to enterprise level networks and devices. It is often used in conjunction with Layer 2 tunneling protocol to securely tunnel low-level network traffic. And one of the most popular for smaller organizations and individuals is OpenVPN, which is open source and provides low network latency. It is important to again remember that the internet and public routing of traffic is inherently insecure, and there is no way to send traffic unencrypted across a public route and consider that to be secure. So how do we secure that traffic? We use encryption layers. Now we have, as I mentioned, three general types of virtual private networking software in pfSense, and the lowest level is the Layer 2 tunneling protocol, and that provides unencrypted tunnels with low latency and low overhead, but no encryption and limited authentication methods. We will often want to tunnel low-level Layer 2 network traffic, but we will want to do so securely, and we will wrap that inside a layer of encryption using IPsec. The single layer of encryption route is to use either OpenVPN or IPsec to secure the traffic from one location to another. And if you want to be extremely tricky, you can encrypt the traffic inside of those tunnels using an SSH tunnel to provide yourself with the ultimate form of network security and traffic flow across a public route. Taking a look at common problems that a virtual private network can solve, we can secure traffic over insecure routes, as I just mentioned. We can also use this to join physically disparate networks, so two networks that are separated from each other physically but need to operate as one network. And we can also use this to provide a secure ingress channel from mobile devices into the internal network. And these are just a couple examples. Why does encryption matter? Well, it matters because unencrypted network traffic can be captured, profiled, and/or altered at any point along the route that it travels. So that means that unless you know and trust every single network point that will be crossed by your traffic, then you should encrypt that traffic. All unencrypted traffic is vulnerable to manipulation, and any point along the network can compromise that packet stream. That means any server, any router, any wire laying anywhere across land or sea can be tapped into and can compromise unencrypted traffic. Many security failures start with the lack of encryption on some source of data or traffic. A malicious actor can hijack sensitive information from unencrypted traffic sources, such as usernames and passwords, or personally identifiable information, financially identifiable information, or medical information, and even intellectual property. Using unencrypted traffic, one's behavioral patterns could also be profiled so that you could be categorized for some reason, such as marketing, or to discover exploitable patterns in your behavior. And if your traffic is unencrypted, then the data streams could be logged and/or changed along the way, which would enable the manipulation of history, context, or content. These methods can also be used to discover the types of services and providers that you or your network services are using so that they can then be targeted for further exploitation. Now that we have had a brief discussion about the hows and whys of traffic encryption and secure remote access, we can move on to our next lesson.